Yeah. So yesterday we were discussing the basics of gravitation. Then we started with the concept of principle of superposition, right? So we saw what is principle of superposition of gravitational forces. Okay. Now see, we will do a problem. So problem based on principle of superposition. Okay. So I'm taking a very simple problem. Listen. I'm saying there are three masses of equal value which are kept at the vertices of an equilateral triangle. Okay, they are kept at the vertices of an equilateral triangle. There is a fourth mass of value of same value m that is placed at the centroid of this equilateral triangle. Find force experienced by the mass at centroid due to other masses. So that is a question. So how to solve? How to solve this? So first, second, third, and let's call this mass as fourth. Okay. So force between the first mass and the fourth mass will act in which direction? So force experienced by the fourth particle due to the first particle will be in which direction? I've asked a very simple question. So unless you're going to answer, I'm not going to proceed. This I had explained yesterday completely. I was concentrating on this part. So force between the first and the fourth particle will act in which direction? Siddesh.
Upward.
No, why you're not telling? Upwards means upward which direction? It should be along. It should be along the line joining both. So what is the name of this force? F. I've given a naming structure yesterday.
1/4.
So force experienced by the fourth particle due to the first particle. Similarly, due to the particle at 2, in which direction will it experience? F43. Okay. So, what is the value of F41, guys? G, mass of both the mass particles divided by the distance between them square. What is the distance between them? What is the distance from the vertex to the centroid in an equilateral triangle? We'll use little bit of geometry, guys. Listen. For nothing, you're opening your mouth. I don't know what. I don't know even if you're learning something. So, can you at least tell what is a centroid? What do you mean by centroid?
The center of a triangle.
Center, how did you obtain it?
Sir, where the medians intersect.
That's right. So the point of intersection of medians. For an equilateral triangle, the medians and the perpendicular bisectors are the same. So median means something which divides the triangle into two, divides the base into two equal parts. I've written it also. Okay. So we know that this is going to be 60 degrees. So what is AP, guys? AP divided by A by 2 is how much? It is tan 60. So AP is equal to root 3 A by 2. So AC is nothing but AP minus PC. Find out what is PC and tell me.
Sir, the question is not given equilateral of a triangle, sir. Then how can we take 60 degrees?
What did I draw here?
Okay, sir.
So what is PC? So PC divided by A by 2 is how much? So this will be 30 degrees. So that will be tan 30. That is 1 by root 3. So PC will be A by 2 root 3. Okay, the easier way to solve this is, observe, if this is C, then BP divided by BC is cos 30. So which implies BP divided by, sorry, yeah, BP is A by 2. A by 2 divided by BC, cos 30 is root 3 by 2. This and this will get cancelled. So BC will be equal to A by root 3. So the distance from any vertex to the centroid of the triangle is, oh, this is C, I'm sorry. I'll take it as G. So BG will be equal to A by root 3. So the distance from the vertex to the centroid of the triangle is 1 by root 3 times the side of the triangle. So this side is A by root 3, this side is A by root 3, and this side is A by root 3. Find the force and tell me.
Sir, one question, sir.
Tell me.
Sir, after AP divided by A by 2 is equal to tan 60, what is the procedure we follow, sir? How AP is equal
Leave
to...
that. Leave that.
Sir?
That is a slightly complicated procedure. I gave you an easier way to solve it. You can follow this method. If you want to know the idea, I will tell you. I found out AP, I found out PG. AP minus PG is what is AG. That is the idea I followed. But that's a complicated way. You can directly go with this. So I'm repeating it. The distance between the vertex and the centroid of the triangle is 1 by root 3 times the side. So F41's magnitude will be equal to G into M divided by A by root 3 square. Similarly, what is F42?
Will be the same, sir.
Yes, it is. F43 is also the same. But what is not same?
Directions.
Yes. So the directions are not same. So if I call F41 is equal to F42 is equal to F43 is equal to F, then if this is F, this is F, and this is also F, okay, then what will happen is the forces which are not inclined along X and Y direction can be resolved into components. Means this force and this force can be resolved into two components. So for that you need to know the angles, right? So it is 30. If this is 30, this will be 60. This will be 30. So it will be F cos 30 this side and F cos 30. Here it will be F sin 30 and downwards will be F sin 30. Okay, what are the two forces that will get cancelled? So if you take this as a basic coordinate system, x-axis, y-axis, this is x dash and this as y dash. So what are the two forces that are along x direction which will get cancelled?
F cos 30.
F cos 30 and F cos 30 will get cancelled. Similarly, along y direction, the sum of all the forces in y is equal to capital F in upward direction minus F sin 30 plus F sin 30 in downward direction. So F minus F sin 30 is F by 2 plus F by 2. What will be the answer? So from this we can conclude that the net force acting on the system is 0. Okay. So I'll give you another problem. You keep trying. I'll be back in 5 minutes. If there are 4 masses of equal value which are kept at the vertices of a rectangle, and there is a mass of capital M that is kept at the point of intersection of diagonals of the rectangle, that is the center of the rectangle of sides A and B. Find force experienced by capital M due to the system. Find it out. Yes, students. What is the answer? So what is the answer for this question?
Sir, I got GMM divided by A square.
How much?
Sir, GMM divided by A square.
Divided by A square. This is a. I asked what is the final answer? The net force experienced by it. This is wrong. See, number the forces, number the masses. Okay, 1, 2, 3, and 4. Okay. Between M and capital M, there will be a force in this direction. Here it will be in this direction. Here it will be in this direction. This direction.
I have a
Say
doubt.
4A square.
Is it 0, sir?
That's the answer. So F51 is how much? F51 is equal to G capital M into small m divided by the distance between 1 and 5 square. What is the distance between 1 and 5? If you drop a perpendicular, this distance will be B by 2 and this distance will be A by 2. So divided by root of A square by 4 plus B square by 4 the whole square. So G capital M into small m divided by A square plus B square divided by 4. Okay. Similarly, F52 will also have the same value. This will be the value for F53 and this will be the value for F54 also. Okay. So if I call all these forces as F, then the way the forces are acting on M are F, 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 and F. Okay. If you observe, these two forces are of equal value, they get cancelled, and these two forces are also of equal value, they will get cancelled since they are anti-parallel to each other. So what will be the net answer?
0, sir.
So an important conclusion to be made from here is, if you have a regular shape, I'm repeating it, if you have a regular shape with all the masses in the corners, with all the masses in the corners of the same value, whatever is the mass that you're trying to place at the center of it, the force experienced by that center particle will be 0.
Can you say again, sir?
I have a doubt. In this sum, can
Yes.
we use property of rectangle? Diagonals
can.
bisect each other.
Yeah, you can. For any regular shaped objects, if the masses placed at the corners are of equal value, whatever is the mass kept at the center of the shape, force experienced by the mass at the center will be 0. It is happening purely because of symmetry. So this is the outline. Got it? I hope it is clear.
Understood.
Yeah. So, wait, we'll go to the next part of this chapter, that is acceleration due to gravity, right? So the heading is acceleration due to gravity. That is the value of g. So what is the value of g that we know on the surface of Earth?
9.8.
So g is 9.8 meter per second square. But let's find out why. Okay, that's what we are going to see. So write it down. The first is value of g on the surface of Earth. Okay. So what we are going to do is we'll consider Earth. So Earth is approximately considered to be a sphere on which, let's say, on the surface of it there is a mass m that is kept. So this mass m will experience a force towards the center of the Earth, and we know that the Earth's mass is concentrated at its center. Okay. So I'm writing down all the points. Consider a mass m placed on surface of Earth. It experiences a force mg towards center of Earth. Next point. We know that the mass of Earth is concentrated at its center. Okay. So from this, what I'm going to conclude is the gravitational force existing between Earth and Mars is the weight of object. Okay, that is. So, what is the gravitational force between capital M and small m? That is G, capital M, small m divided by the distance square. The distance between capital M and small m is nothing but the radius of the Earth. So, I will rather write it as RE square is equal to, and M is, capital M is also ME. Okay, this will be equal to the weight of the object, that is mg. So m and m will get cancelled. From this we get g is equal to capital G m into E divided by RE square. Okay, now if you take the value of g, so what is the value of g, guys?
Sir, what is RE square, sir?
Radius of Earth. 6.67 into 10 power minus 11. Mass of Earth is 6 into 10 power 24 kilogram. radius of Earth is 6,400 kilometer or 6.4 into 10 power 6 meter. If you take all these values and substitute it in the above expression, then the value of G will come out as 9.8 meter per second square. That is how we have derived this value.
Sir, can I say why M was eliminated?
Why?
Sir, why M was eliminated, sir?
I didn't eliminate, they got cancelled.
Sir, you said it is not same for all. Okay,
When
sir.
did I say it is not same? I never told it is not same. See, what is that I've written? Gravitational force existing between Earth and Mars is equal to the weight of the object. Gravitational force is this value. Weight of the object is mg. So small m and small m got cancelled. Whatever I've written, I've converted to mathematical expression. That's it.
So I have a doubt.
Yeah, tell me.
As we go towards the center of the Earth, sir, will the value of gravity change?
Yes, it will change. It will change. That's what we are going to see. So that's why I told the heading is value of G. That is the acceleration due to gravity on the surface of the Earth. Okay. The next topic that we are going to see is variation of G with altitude. That is, if you go away from the center of the Earth, what is going to happen is what we are going to see. So mass of the Earth is concentrated at its center. This distance is RE. So let's say there is an object of mass m which is placed at an altitude of h. Okay. Let m be placed at an altitude h with respect to surface of Earth. Okay. So weight experienced by the block is equal to gravitational pull between Earth and Mars. So what is the weight experienced by the block? It is m into, here I am not going to write g, rather I will write it as g dash, because the acceleration due to gravity is going to change with altitude. So m into g dash is the weight of the object, that will be equal to capital G into mass of Earth into mass of the object divided by RE square. Sorry. Divided by, what should I write, guys? Tell me, what should be the denominator?
RE plus H.
Yes, it is RE plus H the whole square. So again, small m and small m will get cancelled. G dash will be equal to G into ME divided by RE plus H. Okay.
So what is G dash?
That is the acceleration due to gravity at some height. So here, acceleration due to gravity is G dash. It is no more G. It is no more 9.8. As you move away from the surface of Earth, it keeps changing. That's what the mathematical expression says. So G dash is the acceleration due to gravity at height h.
So as we go higher and higher, gravity will decrease.
It will decrease, yes. Because you're going away from the planet, right? Its pull capacity will decrease. That's what we learned yesterday. Force is inversely proportional to r square. So when the distance between them is getting increased, force will decrease. When force is decreasing, acceleration will decrease. So are you clear with this expression? Similarly, if you have a situation where h is very much less than re, from this we can conclude that h divided by re is very much less than 1. Okay? So are you guys able to understand what I wrote? So suppose this is the surface of the earth. Suppose this is the surface of the earth. You have moved to certain height where this height is very much less than re. See, radius of the earth is 6,400 kilometer. Let's say you are moving only 10 kilometers away from the surface of the earth. Then what is going to happen? Because 10 kilometers is very small compared to 6,400. Right? So when that is going to happen, let's see what is the value. G dash is equal to G into ME divided by RE plus H the whole square. This is from 1. So from this we can write G dash is equal to G into ME divided by, if I take out RE outside, then I'll get RE square into 1 plus H divided by RE the whole square. Did you guys understand what I did? I just took out RE outside, which came out as RE square. Then inside it is 1 plus H by RE. So from this we get G dash is equal to, what is the value of GME divided by RE? So we have seen this value, GME divided by RE square. GME divided by RE square. It's nothing but the acceleration due to gravity on the surface of the earth. So can I write this as G into 1 plus H by RE? Observe the way I'm writing, okay? G into 1 plus H divided by RE, the whole power minus 2. Can I write it like this?
Yes.
Okay. Now listen, I'm going to tell you one important fact. 1 plus x the whole power n can be approximated to 1 plus nx if the value of x is very much less than 1. Okay, this is a mathematical term. Please make a note of it. 1 plus x the whole power n can be approximated to 1 plus nx if x is very much less than 1. So this came from the concept of binomial theorem. Okay. So why I use this concept is, I wrote h divided by re to be very much less than 1. If you observe, h divided by re, if I call it as x, then 1 plus x the whole power minus 2, using this form, how can I write it as? Guys, I have asked a simple question. I'm saying 1 plus x the whole power n is 1 plus nx if x is very much less than 1. I have taken h divided by re to be very much less than 1. So if
1
you observe,
minus 2h by RE.
that's right. 1 plus of minus 2 into h divided by RE. So G dash will be equal to G into 1 minus 2h divided by RE. So there are two formulae for variation of G with altitude. One is G me divided by RE plus h square, and the other is G into 1 minus 2h by RE. Okay. When to use this? When to use the formulas? So you use one when h is comparable to RE. When h has a comparative value with RE, we use it. Here, you will use this formula when h is very much less than RE. Okay. So I'll just give you two example problems to understand when to use what. So write down. At what height above the Earth's surface, the value of G is half of its value on Earth's surface. Given radius is 6,400 kilometers, that is the radius of Earth. Second question, only two questions, okay? Find the percentage decrease the weight of the object. Find the percentage decrease in the weight of the object when taken to a height of 32 kilometers above surface of Earth. Again, RA is equal to 6,400 kilometers. So these are the two problems that we are going to see now to understand how to apply them. Because I told you there are two formulae, right? What are the two formulae, guys? G dash will be equal to GME divided by RE plus H the whole square, or G dash is equal to G into 1 minus 2H by RE. So look at the first question. They are saying at what height above the Earth's surface the value of G is half of its value on Earth's surface. So solution for the first one. Given RE is 6,400 kilometers. Next. Acceleration due to gravity on surface of Earth is G. Height H is G by 2. So this is G dash. So acceleration due to gravity at some height H is G by 2. That height H is what we need to find. So I'm going to use the formula G dash is equal to GME divided by RE plus H the whole square. Okay. See, I'm going to do a small manipulation to this. GME, I will divide it with RE square and multiply it with RE square. And the denominator, I'm not disturbing it. Okay. If you ask me why I did this thing, because there is a formula for GME by RE square. What is it?
G.
Small g. So G into RE divided by RE plus H the whole square. This is what is G dash. So G dash, if I write it as G by 2, is equal to G into RE divided by so this and this will get cancelled, which implies RE divided by RE plus H is 1 divided by root 2. So when you cross multiply, root 2 times RE is equal to RE plus H. So what will be the value of H guys? H is equal to root 2 minus 1 times
Sir, can you explain the sum again, sir?
from where?
Sir, from G dash is equal to GME divided by RE plus H the whole square.
See, that is the formula I gave you here. So what I did is G dash is equal to GME divided by RE plus H the whole square, right? We know that small g is equal to GME divided by RE square. This you know, right? This you have derived already. So I have GME here. So I need an RE square in the denominator for me to write it as small g. For that, I divided the denominator with RE square and multiplied with RE square to compensate it. If you observe, these two expressions are the same. Now, what is GME divided by RE square? That is small g. Then you will have RE plus H the whole square. Okay. This value is what is G dash, but according to the question, G dash is nothing but G by 2. Because they told 50%. The value of G is half of its initial value at the surface. So it will be G by 2. Now I cancelled these two and then I proceeded. Then you will get root 2 minus 1 into 1.
Sir, so normal G is when acceleration is at the surface of Earth and G dash is at some altitude.
Yes.
Okay, sir.
So in questions, we should find the actual value, no, sir. We can't give it with RE.
You can't leave because RE is given 6,400. So root 2 minus 1 is how much? Root 2 is 1.414 minus 1 is 0.414. So 0.414 into 6,400 kilometers. That will give you the answer. So it will be approximately 0.5 into 6,400 is somewhere close to 3,000. So your answer will be less than that value. I hope it is clear.
Yes.
Okay. Now comes the next problem, that is so the next one is find the percentage decrease in the weight of the object when taken to a height of 32 kilometers. So if you observe, 32 kilometers is very small compared to 6,400. So in this case, what will happen is, since H is very much less than RE, that implies G dash will be equal to G into 1 minus 2H divided by RE. Is that clear?
Yes.
So G dash will be equal to G into 1 minus 2 into H is 32 divided by 6,400. So this will be 64 and this will be 100. So it will be 99 G by 100 guys. So G dash at a height of 32 kilometers is almost 100% G. It is only 99 by 100, which is 0.99 times G. You're able to understand. So there is not a very great difference. But what are they asking? Find the percentage decrease in weight. So write down the formula. Percentage change is given as final minus initial divided by initial into 100. Okay. So what is the final value that you have? M into G dash minus initial value you have is mg divided by initial is mg into 100. Why I wrote m is because they didn't ask the decrease in acceleration due to gravity. They asked the decrease in weight. So if you take out m, then it will be g dash minus g the whole divided by g into 100. So g dash is what? 99 by 100 minus 99 g by 100 minus g by g into 100. So what will you get? It is 1%. So there is a 1% decrease in the weight of the object. So the minus sign there indicates that there is a decrease in value. Clear?
Sir.
So here we don't have to consider mass, no, sir.
See, actually, mass is not given in the question, but look, if you look at the question, they have asked weight. No, weight means it has the gravitational acceleration has to be multiplied with mass. That is why I took. But I knew that mass will get cancelled, and that is the reason they didn't give it in the question also.
Okay.
So this is all about acceleration due to gravity with height. So next class, what we will do is we will see with the depth, and there are two more concepts which are called as escape velocity and orbital velocity. With that, this chapter is over. Next class, we can actually complete it, or maximum 2 classes. With that, first volume will be over. Okay. Any other doubt from today's class?
No, sir.
No, sir.
Okay. Just wait, don't leave.